In this video, we are going to study instrumental variables with two-stage least squares in Python using Jupyter Notebook. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into the web browser where the Jupyter Notebook is located. So the first step regarding the Jupyter Notebook is that we need to insert a new cell below, and we do so by clicking on the Insert Cell Below button. And the first step regarding the code is we need to import the corresponding packages, therefore we comment this as step 1, which is packages. And we are going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.formula.api as SMF. We're importing that feature from statsModels for multiple linear regression calculation. And last, we're going to import linearModels.ib.model as LM, and we're importing that feature from linear models for two-stage least squares. To run these code lines or this cell, we can either click run or we can press Shift Enter on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named housePrices_object, which is equal to, and here we'll be using SM feature from statsModels.datasets.get_our dataset, and we open parentheses. First parameter, which is data name, equals to, within quotations we have house prices, comma package, equals to, within quotations AER, comma cache, equals to true. So what we're doing here is the following. We're downloading house prices object from our package AER, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within house prices object. Therefore, we're going to create a new object named house prices with only the data, therefore equals to house prices_object, and we're going to get its .data attribute. So we want to print part of this data, and we do so with print, and from the house prices object we're going to print its first rows of data with the head method, open and close parentheses. So to run these code lines, we're going to now press Shift Enter on the keyboard, and we can see the head of the data being printed. So we have the first 5 rows and all the columns of data. In this video, we're going to focus on the following columns, which are price as a dependent or explained variable, which is being explained by the independent or explanatory variables of lot size and bedrooms, and we will have as instrumental variables driveway and garage, which is the number of garage places. If you want to read the full documentation of this data, you can do so with the following code line, which is print, and from house prices_object, we're going to get its .2_doc attribute, and we press Shift Enter on the keyboard, and here we see the full documentation of this data. So now we can continue with step number 3, which is the model. For this, we're going to create an object named MOR1, which stands for multiple linear regression 1, and it is equal to, here we'll be using SMF feature from statsModels.ols function, which is ordinary least squares, and within it we have the following parameters, which are formula equals to, within quotations, because it is a string, we have price as the dependent or explained variable. Special character means being explained by the independent or explanatory variables of lot size plus bedrooms, comma data equals to the house prices object, the one with only the data, and we go ahead and fit this regression, open and close parentheses. So to run this code line, we press Shift Enter on the keyboard, and then we continue with step number 4, which is instrumental variables. Instrumental variables. And as this is just a title, we're going to press Shift Enter on the keyboard, and here we are going to continue with two-stage least squares. And for this, we're going to create an object named mData, which is the model data together with a constant or intercept column, therefore equals to SM feature from statsModels.add_constant and within we have the parameters data equals to the house prices object, comma, prepend equals to false. And then we continue with the creation of the object name MLR2, which stands for multiple linear regression 2, and it is equal to, and here we'll be using LM feature from linearmodels.ib to SLS, which stands for instrumental variables, two-stage least squares function, and within it the following parameters, which are dependent equals to, and from mdata C object we're going to get its price column, comma, exog equals to, and from mdata C object with double brackets we're going to get constant, const, together with bedrooms column. Then we have comma, endog equals to, and from mdata C object we're going to get its lot size column, and then comma, at the following row we have instruments equals to, and from mdata C object with double brackets we get driveway, comma, garage, which is the number of garage places. And we'll go ahead and fit this regression with the following parameters, which are COB underscore type, covariance estimator type equals to homoscedastic, and debiased equals to true, so that the covariance estimator is adjusted for degrees of freedom. So the way two-stage least squares works is as follows. We have the original model in which price is the dependent or explained variable, which is being explained by the independent or explanatory variables of lot size and bedrooms. But we're going to make an important distinction between these two, and that is that lot size is the endogenous explanatory variable because it is assumed correlated with MLR1 model error. And bedrooms is the exogenous explanatory variable because it is assumed not correlated with MLR1 model error. And then we have driveway and garage as instrumental variables. These instrumental variables have three requirements. The first is that they do not appear in MLR1 model, which is the case. The second is that they are assumed correlated with lot size endogenous explanatory variable. And the third is that they are assumed not correlated with MLR2 model error term. And two-stage least squares estimation is done as follows. So first we have the first stage regression in which lot size, endogenous explanatory variable, becomes the dependent variable, and bedrooms, exogenous explanatory variable, together with driveway and garage, instrumental variables as explanatory variables. And then we have the second stage regression in which we have price as the dependent variable, and then instead of having lot size we have the first stage regression fitted values together with bedrooms, exogenous explanatory variable as explanatory variables. And important observations regarding two-stage least squares are the following, which is that notice that doing two-stage least squares manually with OLS function would estimate correct coefficients but incorrect standard errors and incorrect f-statistic. Also, notice that in this two-stage least squares estimation, as we can see within the parameters within fit, it is assumed that MLR2 model errors are homoscedastic or with constant variance. So the next step is we're going to compare the results between the original model and the two-stage least squares. So let's begin with coefficients, and we do so with print, and we get from MLR1 object.params and similarly MLR2.params. And now we're going to run all these code lines by pressing Shift Enter on the keyboard, and we can see right here the results being printed. So first we have the coefficients for the original model with intercept, lot size, and bedrooms, and below we have the coefficients for the two-stage least squares with constant, bedrooms, and lot size. So two important observations. First, we see that the order of independent variables is different, so it's been printed differently. And also for the two-stage least squares, as you might remember, instead of having lot size data from the house prices object, we have the first stage regression fitted values. So when we compare these coefficients, we see that they are different. So now let's continue to do the comparison of their t-statistics. So we do so with print and MLR1.t values. that's where they are found, and from mlr2.tstats. So let's go ahead and press Shift Enter on the keyboard, and we can see the results being printed. So first we have the t-statistics from the original model, then below we have the t-statistics from the two-stage least squares. Remember the different order regarding the independent or explanatory variables, and we see that the t-statistics are different. Then we're going to do a comparison of p-values. So we do so with print and from mlr1.p-values, comma, and then we have mlr2.p-values as well, and we press Shift Enter on the keyboard. And first we have the p-values from the original model, and then below the p-values from the two-stage least squares. Again, remember the different order regarding independent or explanatory variables, and we see that the p-values are different. And last, we're going to do a comparison of their f-statistics. So we have here print and from mlr1.f-value, comma, mlr1.f_p-value, and then we do so with print mlr2.f_statistic. So to run this code lines or this cell, we are going to press Shift Enter on the keyboard, and we can see right here the f-statistic and associated p-value from the original regression, and below the f-statistic and associated p-value from the two-stage least squares. And when we compare the f-statistics, we see that they are different as well. Okay, so with this, we finished with this code file, so we can go ahead and save it. And with this, we also finished with this video. Thank you for watching.